Next thing we're going to do is definition 1.6. This is called the domain, the range, and more. You see it? You see the fundamental problems? They're not there. Yeah. So domain. Sorry, I should spell it out. Domain, range, and more. All right. So let A and B be sets, and let R be a relation from A to B. So what does it mean that R is a relation from A to B? And I almost want to go back to my homeboy Sam. Sam, too legit to quit. Hey. Sam, you got it, man. All right. So when we're thinking about, let me ask you this. When you think about a function, what is the domain in terms of the ordered pairs for every element of the function? Is the domain the left element or the right element? Left. Okay, so let me ask you this. Could you guess what the domain space of R is? The domain space, I guess I should write it all out. The domain space of R is A. It's the set from which the domain elements are chosen. The domain space, so I would write this in little notes, the set from which domain elements are chosen. What's the domain of a set? Forget about this for a second. Let's go back to functions from Math 1A. And let's do a really, really special function. Let's see if I can get one for you. Yeah, let's do this function. Let's do 3 minus x square root. Okay, so let's just do a quick analysis here. What's the domain space? So if you think about this thing as y, and then you're looking at the function as a set of points, this is going to be x comma y, and the claim is that y is going to be the square root of 3 minus x. So that's the set theoretic notation there, and we'll come back to that. From what set are the inputs chosen? R. So when you think about the left coordinate there, the inputs are chosen from R, right? What is the domain of this function?
R less than 4.
It's the set of all x such that 0, sorry, that's a 3, sorry about that. What's the biggest x could be? 3. Can it touch 3? Okay, what's the smallest x could be? Yeah, I guess that's true. Okay, why? It's the set of actually used domain space elements. Okay, well, how would you write that set theoretically? So if I wanted to write the domain of my relation, this is going to be the domain of R. Well, what is that? It's the set of all. Well, where should the domain, where should those elements come from? Should come from the domain space. What should be true about those elements? Why is the number 4 not in the domain? Because there is no corresponding range space element. There's no corresponding element in B, in the codomain, such that those two elements exist in that relation, right? So what's the domain? It's the set of all elements of my domain space such that there is at least one B element of capital B such that A comma B shows up in my relation. So the way that I would set this, the domain space, what is it? all possible elements that I could choose for my first coordinate. What's this one? The first coordinates from A, I could not have said that better, that are actually used. Okay? Dun 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 dun. Could you guess what the codomain is? It's B. Yeah. So we would say in English, the set of all possible what? Second coordinates. Okay. What's the range? Could you guess what the range is?
All the codomain elements actually used.
Yep. The range of R is all the codomain elements actually used. Well, let's see this. How did we define the domain elements that were actually used? The set of all things in the domain space such there's at least one thing in the codomain that gets mapped to that element in the relation. So what's the corresponding set theoretic definition of the range? It's the set of all B in the codomain such that there is at least one A element of A such that what is true? A comma B is an element of R. Analogy. The domain is to the domain space what the range is to the codomain. One of them is the pre-image. One of them exists in the input space. One of them exists in the output space. True or false? All elements of the domain must be in the domain space.
True.
Why? The domain is a subset of the domain space that's actually used. True or false? All elements of the domain space must be in the domain. False. Give me a counterexample. Touchtone telephone. We'll get there in a sec. This stuff's so cool. This stuff is, I can't, this is just like, this blows my mind how fun this is. I know. We're all on the same page, right? You all bleed linear algebra? Say yes. Yes. Oh, A+. In my heart, not transferable for legal tender.